Hello, everyone. Welcome to this session. Today, we're going to look at the program analyst component of the AutoScholar Advisor system. So to access the program analyst, you'll want to go to your institution's implementation of the AutoScholar, and that's typically at the URL autoscholar.institutioncode. And country code and things like that. So once you've accessed the AutoScholar hub, then you'll see some of the components you might be familiar with, and you'll find the AutoScholar here. So if you click on that, then that's going to load up the program analyst. Right, and we're just going to look at it through this view. So when the system loads up, it's going to present you with a list of academic programs, and you'll find an option down here, do anonymize, which I'm going to turn on because we don't want to reveal the student names, and even course codes will be masked out. And please note that even the student results will have a small noise value added to it so that you can't even triangulate based on the student results. Right, so we will pick an academic program. So you can select an academic program by clicking here. And by the way, you want to select academic programs with sufficient data. So the program analyst works best if you have at least the number of program years. So let's say it's a 4-year academic program plus 2. So typically we are interested in having something like 5 or 6 years of data. So this program has a fairly good history of data. If you select others here, you'll see some of those have only been in existence for 1 year and so on. So what you want to do is click here and then view the number of years here. So that will, the moment you click here, it will load up the number of years that that program. All right, let's just do it. So if I click here, for instance, you can see 22 students only in 2020. And what you can typically do is filter this list by number of students. So clicking here, and then you can typically the programs with larger numbers of students will be in existence for greater periods of time. So if you click here, you can see more years in these academic programs. So I know this one has a good set of data. So let's look at this program. And by the way, if you click down here, so as you click here, it will populate data down here. So if you untwirl these sections, then you can view the courses undertaken by students in this academic program and the students registered in this academic program and so on. So all of this is just around selecting your program. So to select your program, you come here and so you can filter and select. So once you've selected the program of interest, you can click on Analyze Program, and that's going to load up 6 years of data for all the students. And so that typically involves something of the order of 10,000 records. So it will take a few seconds. Besides just loading the data, it's also analyzing the data. And then it's going to give us a summary, which will appear here. And then below that summary, you'll see the other sections that give more detail. So for this program, here's some characteristic metrics. So we've got 82 students in the 2015 cohort entering. And then on average, this program is graduating 80% of the entering students. There are 4 gatekeeper courses that we have to keep an eye on. And there are 37 students who have some progression issues, which we'll look at just now. We can also see here that we have 66. So out of the 82 students, 66 are graduating in minimum time, and about 16 are graduating in minimum time plus 3 years. We can also look at the numbers of students who are registering in this program over time. So it started out with just 3 students, and then this program has grown nicely to now about 3,000 students. And by the way, this means all students registered in the program. So it doesn't mean 3,000 students are entering. It means that among all the years, that's the number of students in the system. You can typically divide by around 3. So it's probably about 1,000 students coming in to each as new entrants here. Now we get onto a bit of an analysis, right? All of this was just basic data that you can probably get already. Maybe the cohort analysis would take a bit more work, but this is typically stuff you see in most cases. Now, here's something a bit more interesting. This is a so-called population balance. So it's showing us here among the new entrants. So we've got 82 new students coming in, and it looks like all 82 students make it into the second year of study, and there are no recycle. And please excuse me, I'm from a chemical engineering background, so I talk about recycle rates and things like that. And education people probably don't like that too much, but I think of this as recycled students who fail, who don't manage to get to the second year of study. So they fail, but they go back into the same year of study. So there are none of those students in the first year here, and there are no students who fail and exit the program. In the second year, however, 10 students fail and re-enter the same second year, and there are 10 other students who fail and exit the program completely. So we've got 10 students on average circulating here, and you've got 72 students. Out of the 82 coming in, 10 are completely exiting, and 72 are then going on to the third year of study. And then there in the third year of study, you've got 14 students recycling around, and you've got a loss of 4 students who are failing out of the program. Failing out or dropping out, that's something that still needs to be unpacked, the reasons for their exit here. Then going into the fourth year, you've got the 68 students going into the fourth year. You've got 16 students circulating around there. And then you've got 66 students making it into graduation. So that gives you a view of how your students are distributed over the years there. You'll see some garbled text down here. So down here, you've got the text version of this graph, right? You can see it's nice to get a sense for the operation of this program from this picture, but it can be a little difficult to read, although you can scroll around and zoom in using your typical mouse operations. But you can also get the text here. So you can hear in your various years of this, the various semesters of this academic program, you can also see what core courses are positioned in each of these semesters. And by the way, because we switched on anonymization, it looks garbled here. Without anonymization switched on, you'll see here the course code that you are, like your Maths 101 and things like that. So it's much more descriptive when you don't switch on anonymization. So it's figured out from the student data which courses are core and need to be taken by all students in that academic program. It's also figuring out which courses are core electives and the number of credits in each case, and then which are free electives. And it just shows 0 credits because on average, I think in this case, students are not really taking free electives in the first semester. And then it's showing the same information that we talked about in the graph up here. So that's the more text view of it down here. Then going past that, it's also showing us the courses. So this part is a bit more evaluative. Here, this is more like information. And some of this you may already be able to access from your typical reporting that you have in place. So, well, not so much the population balance, but you probably know what your core courses are and so on in your academic program. It's typically published in your program handbook. However, this has been determined from the data, right? So there is an automated method in the AutoScholar to figure out which the core and core elective and the free elective courses are. So that's been worked out from the student data. And now it's starting to show us information about the operation of the program and where we need to direct attention to improve performance. So in the first semester, there are some courses which are causing our minimum time students to become extra time students. And of course, we just saw that there were no students that were recycling in the first semester. However, it's showing us here that among all the minimum time students in the first semester, that these are the top courses, or well, these are the courses with the highest fails. So a student may still be regarded as being in the second year, but dragging another course. And this gives us a sense for which courses students tend to drag, and that will often cause them to slowly become extra time students. So the emphasis here is not just on looking at which students failed out. The emphasis is on staying on minimum time. And that's something we want to move towards, right? Quite often we have this, this view that's focused on the failure, whereas what we could do is look at the pass and the minimum time and try to stay more closely on the minimum time, and that will take care of the failure rate automatically. So in that first semester, these are the courses, and again, this is anonymized, apologies, but with anonymization turned off, it will show you the course codes here, and it shows us the number of students who have failed that course. So even though it looks nice from this picture that all the students in first year go into second year, there are something like 37 students who are dragging this course, and that puts them at risk of becoming extra time students. So 37 students dragging here, 4 students on these. And then you can see in the later semesters, there are students dragging courses. And this is all from the minimum time group. So these students were still on minimum time going into the second semester and the fourth semester and so on. But they ended up needing to carry these extra courses into later years. Carry, or they could have become extra time students. So if you just compare the numbers here, that tells us that in this whole academic program, this is the course that needs special attention for us to get more students onto the minimum time to graduation. Then down here, it's again trying to shift our focus to students who are on track to graduate in minimum time. So again, anonymization is turned on, and so you would normally see a student number here, but it's highlighting to us the students who are doing unusually well, and perhaps those students especially need to be counseled that they really need to try and stay on track. So again, trying to shift the focus towards success, towards keeping more students on a track for success. Furthermore, besides the minimum time type of data, we can also say that there is possible risk in some of the courses. So these are actually course codes, anonymized. And it's saying that this is a possible gatekeeper course because number one, it is a core course and it takes extra time to complete this core course. And core courses are typically, prerequisites to later year core courses as well. Many people prefer the term modules, and it doesn't sound nice, a core course. But anyway, so these courses in particular have some progression issues, possibly offering some progression challenges. And then this course is not a core course, but students are, this is possibly a core course, but students are passing it later than expected. So this should actually say impacted course. So this is possibly a course which students are taking on later than they normally would. So according to the academic program that the Autoscholar has worked out, it's saying that this course, students should be undertaking it earlier than they are. So on average, students are taking it in year 3.54, when more of them should be taking it in year 3. So this course is possibly impacted by some of these other courses being prerequisites to this course. Then also among the students, it's looking at each of the students and looking at the number of credits that they are passing and how many of those credits are core courses and how many are core electives and so on. So here it's, so these are all anonymized. So normally it will show the student number here, and it's telling us that this student in particular has a low progression rate. So this student has a low progression rate and a high number of non-core courses. And we see this behavior sometimes among students who are aware that their rate of progress is not high, and they sometimes try to avoid the exclusion rules. So you might have exclusion rules that specify the number of credits you are supposed to pass each semester. And typically in that, we intend for those to be core course credits. But sometimes students will register, they can't register for more core courses, but they will then register for other courses just to get their credit numbers up. And if the rules are that non-core courses are not supposed to count in that, then this is a subversion of the progression rules. And quite often it's very difficult to administer the detection of this. So it's often difficult to figure out that a particular student is overcrediting on non-core courses in an attempt to subvert the rules. But now it's automated, right? The Autoscholar will automatically detect that for you. And so you can click on the student number and that will load up the student profile, and you can check then whether that student seems to be undertaking that kind of behavior, right? So here, by the way, these little numbers are the number of standard deviations. So showing the number of standard deviations away from the mean, it looks like 5 standard deviations above the mean in terms of non-core credits. So it's very likely the student is trying to subvert the progression rules here. Okay, so that's in terms of students. Then down here, we have the so-called progression tree for this program. So this is the combination, the combinations of courses that students are passing. So in the first semester, these are all the combinations of courses that the students have managed to pass. So if you look here, there are 128 credits passed by these students, and you'll see there are a number of 128 credit combinations, and that's because there are some core electives. So there are different combinations of things students can pass here. Then you can see a lower number of credits down here. That's because the students have not passed certain courses. And by the way, on the right here, it's showing these students are. So if you click on any one of these, it's going to show you which students are in there. And you can also see here N is 4. So it tells us there are 4 students who have passed this combination of courses in the first year. So 97 students passed this. So that's a large group. That's the main group, the main minimum time group. 23 students passed this combination, and so on. So the number here is important. It tells you how important that route is. And I'm calling it a route because you can see there's a path building up here. So this is semester 1, the combination of courses, right? Again, these are the anonymized names of the courses that have been passed there. So if you click on this, you can see it's loaded up for us this little graph, and this graph is telling us that among this group, right, where did I click here? So among this group, among these 97 students, there are 88 students who will go on to pass this combination of courses in the next year. There's 1 student who will pass this combination of courses, and so on. So it basically tells us that from this group, this is the combination of courses that group is going to pass in the next semester. And you can follow that through. If you double click here, it's going to give us another list. And now this is telling us among that group. So yeah, among that minimum time group, there are now 96 students here. And among that group of 96 students, 85 of those students will pass this combination of courses in the following semester. And 1 student will pass this combination, and so on. And so as you click here, also it loads the information here. So you can actually read the course codes more more easily here, right? Again, reading on this network. The network gives you a nice visual impression of what's happening, but sometimes you actually want the detail. So it shows you the detail here, and you can also read the students' numbers here, right? So to use this, again, you get the path building up here. So semester 1, 128 credits there, then 80 credits here, and then well, 96 credits is the minimum time group. So as you click here, you can see your path builds up. So there's the 3rd semester and so on. So as you click around here, you are basically looking deeper into the semesters, deeper into the course combinations. So if you want the level of detail in terms of all the progression routes undertaken by students, you can do that using this progression tree. Okay, and all of this was under, let me just see if there's any, right? So all of this was under the summary view of this, the program analysis summary. So if you untwirl this, you can see there are other sections down here. So you can get a bit more information about other aspects of the analysis. Well, in fact, it's showing us the detail behind the determination of all the results that we saw here. So if you want to know how it arrived at these numbers, and also look at more of the detail of any aspect you're interested in, you untwirl that and then you go into the aspect. So for instance, on program structure, and my apologies, there'll be an improvement on this table here. At the moment, it's running the columns together. It's a little easier to see this if we just open it up in Excel. Right, so it's open on my other screen here. So it's showing us, yeah, your course code will be here, and then the number of students. And by the way, this is showing us all the students that have been loaded into the data set. I didn't spend enough time pointing out the difference between the students who were in the cohort and the students, or all the students in the data set, but this is all the students in the data set. It's figured out what year of study and what semester this course is typically taken in. It tries to figure out, is it a core or core elective or free elective? What fraction of students take it, and in what year on average the students take that course. So you can already see how the Autoscholar has worked out some of the characteristics using this estimated academic year of study that starts to tell us about gatekeeper information and so on. So that's under that section. So if you go then to cohort analysis instead, then that data about minimum time student, number of minimum time students, number of minimum time students plus 1 year, plus 2 years, and so on. That's also here. And then under course performance, this is showing us all the detail, well, behind the courses with issues. So again, you can just open that up in Excel. And then you get an easier view of it. And it shows the reporting around that. And then that's the set of gatekeeper courses. So your raw data for that is also here. So it's showing us among the core courses any issues that have been detected there. And you can see here the mean number of attempts, the standard deviation in terms of the attempts, the mean, and things like that. Coming back here, under student progression, this shows us how it's worked out which students have issues in their progression. So your student number appears here, the rate of progression. So this is a derivative, D number of credits dt, that's what that is. And then non-core credits, and if there are any messages, any issues detected, then they will be summarized as messages here. Right. And then the course progression map. So we saw this earlier. So you can navigate your course tree using this method. And down here is showing some of the raw data behind that. So departure from minimum time. So which courses, right? We said earlier, which courses show the minimum time group, which courses are the minimum time groups failing the most of. So this is showing for most, I think all the courses, it's showing then, so among the minimum groups, how many are not passing these courses. So here it's showing for all the courses. Earlier it was showing for the top 3 or something like that. And then your tree, the data for the tree that we saw earlier, that's all here. So you can get the complete view of the tree data here as well. So this shows us for all combinations among all students, the complete data for the tree. Okay, and that's where it is right now. So that's functional. So you can use the program Analyst as it is. In the coming weeks, we expect to receive feedback from the institutions who are actively using the Autoscholar. So there may be some changes to the interface, and it will largely make better sense. We find that as we receive feedback on the Autoscholar, we tend to get a much better operation. So we may put out more update videos as a result there. Thanks very much for listening.